So in number 1, it says given the derivative with initial conditions y of 2 equals -1, find y of 3. So this is a fundamental theorem of calc problem where you are given an initial condition, you want to find a new value, and you need to use the equation you have. So option 1 is to integrate the derivative. So you integrate the derivative, and that gives you the antiderivative, and then you would find its upper and lower bounds. And that gives you the initial condition C. So that's where we we don't really hit the plus C part. So our book is a little goofy that they do this later. So we're not going to focus necessarily on method 1. We are going to go down and look at optional method, which is method 2, which is the fundamental theorem of calc, which says the integral is equal to f of b minus f of a. So in our case, we want to integrate from 2 to 3 of that f prime of x dx. And then we're going to find f of 3 minus f of 2. And then we're going to plug in everything we know. So we know the derivative. We're looking for f of 3. And we know f of 2 is -1. So I would rearrange my terms, take my antiderivative, or integrate that integral from 2 to 3. So 3x squared becomes x cubed over 3. So my 3's cancel. 2x becomes x squared over 2. So my 2's cancel. And then minus 4 becomes minus 4x. And my dx goes away, my integral goes away, and I'm evaluating from 3 to 2. I'm also going to take that plus 1 from the right side and subtract it to the left side. So I'm equal to f of 3, which is really y of 3, which is what I'm looking for. So then I'm going to plug in 3 cubed is 27, 3 squared is 9, 3 times 4 is 12, so I have 27 plus 9 minus 12, minus 2 cubed, which is 8, minus 2 squared, which is 4, plus, because again, that becomes minus, that becomes minus, that becomes positive, 4 times 2, which is 8, minus 1. So positive 8 and negative 8 cancel. 27 and 9 become 36. Negative 12, negative 4, negative 1 become negative 17. And then 36 minus 17 is 19. So what that means is that y of 3 is 19. Good? So that is the fundamental theorem of calculus, part 1. That's what we talked about a lot last week. That's where you have the initial, you're finding the final. So if there is no antiderivative, then we can use our graphing calculators. So here we have f prime equals the sine of x squared. Well, we don't know how to antiderive something that is bigger than x inside sine right now. We don't have that rule yet. So this would be a calculator question. So it says find f of 2. So what I would do is set up my integral again. We have 3 and 2. So we're again we're evaluating from 2 to 3 of f prime of x dx. And again, it would be f of 3 minus f of 2. So you have to manipulate your equation so that you know what goes where. Because this is the one where you work backwards, right? Because f of 2 is the second value and f of 3 is the first value. So if I add that f of 2 to the other side, I get f of 2 equals f of 3 minus the integral from 2 to 3 of sine x squared dx. So -5 minus whatever that value is. I'm going to check my calculator in front of you. Then we got -4.9687. Remember, you need at least 3, but 4 is safe. Alright, we did this page on our homework already, so did I even give it to you? I think I was smart and I didn't copy it in yours. Okay. Alright. So then problems 1 to 2. So it says don't use your calculator. You have y prime equals blank, y1 equals blank, find y2. So again, initial condition problems with fundamental theorem of calc. So y2 would be my upper, y1 is my lower. So I go from 1 to 2 of y prime dx equals y2 minus y1. So that's going to equal the antiderivative of y prime. So that's 3x minus, so that negative 1 over x squared is really like negative x to the negative 2. So your rule is to add 1 to that power, so you get x to the negative 1. But x to the negative 1 means you divide by negative 1, and a negative divided by a negative is going to go back to a positive. So you're going to have 3x plus 1 over x, evaluating from 2 to 1, equal to y of 2 minus 6. So plug in the 2, plug in the 1. 3 times 2 is 6, plus a half, minus 3 times 1 is 3, plus 1, plus 6 equals y of 2. So 6 and 6 is 12. 12 minus 4 is 8. 8 plus a half is 8 and a half. Number 2, f f prime of x equals the cosine of 3x. F of 0 is 3. Find f of pi fourths. You would technically need calculator again, because, or I will show you, I won't give you any trig functions with a number inside. This cosine 3x antiderivative is sine of 3x divided by 3. Because if you think about like the derivative of cosine 3x would be negative sine 3x times 3. So like the antiderivative would be divided by 3. So that's kind of annoying. The problem is you would have to do that. So it would be sine of 3x over 3. So then you'd have sine of 3 pi fourths. So sine of 3 pi fourths, well, you know, any pi fourths is root 2 over 2. So then you have to know where 3 pi fourths is. 3 pi fourths would be in quadrant 2. Sine in quadrant 2 is still positive, exactly. So you have root 2 over 2 over 3 minus sine of 0. Sine of 0 is always 0. So then add 3 to that. Root 2 over 2 divided by 3 is like root 2 over 2 times a third. So you get root 2 over 6 plus 3. And again, I will not give you that 3 in there. You would have just had that root 2 over 2. But I can't tell you like the wrong answer. Like that makes, you know what I mean? Like I can't show you it right now outputting it over 3. Alright, and then 3 to 6 are on your calculator. I think we're pretty good at the calculator. If you think you need extra calculator practice, I'm just going to give you those correct answers right now, and you can go back and try them on your own. So it's 4.932, 2.996, and then number 5. Says a particle moving along the x-axis has position blah 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 with velocity blah 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 at time t equals 5. The particle's position is, so that is almost like in an initial condition for you. So time t equals 5, the particle is at 3, 0. So what that is saying is that x of 5 is equal to blank. Find the position of the particle when t equals 7. Find the position of the particle when t equals 7. So once again, you would be integrating on your calculator from 5 to 7 of 5 cosine t squared dt. It's saying that that is equal to s of 7. So again, you integrate velocity, but the initial conditions or the points you are finding are with respect to position. So s, sorry, not s, we use x. In calc, we can use x or s. So the x of 7 minus x of 5. And then just move that over. 2.7343. And then similarly, here's number 6. It's 24.640 million bacteria. So this is one of those where like they give you the initial condition as 3 million. So you have to make sure you know that your answer is million. And then it's just been a while, so I want to do at least another graph with you. So the other part to the first fundamental theorem of calc was the graphing. So we have the integral from 1 to 4. So 1 to 4. So again, we're talking about that yellow region in there is equal to 6.2. So again, they already gave you that answer. Don't integrate 6.2. This yellow shaded space is 6.2. That's what that means. We know that the initial condition f of 1 is 3. We want to find f of 4. So f of 4 would equal f of 1 plus the integral from 1 to 4 of f prime of x dx. Because again, 4 is the higher bound, so you add the initial condition. So we get 9.2. So what that means is that the function itself at 4 is way up here at 9.2, and at 1 it was at 3. And again, that should make sense, right? The derivative is positive. If the derivative is positive, then the original function is. So in terms of those 2 points, you go from 3 to 9.2, you're increasing. You can add to it and say, okay, the derivative is increasing, therefore it's concave up. Derivative is decreasing, it's concave down. So you could kind of say, oh, well, it's going to go like this, but it didn't even ask you for that. Number 8. The graph of f prime is a semicircle. So they're already implying you need the area of the semicircle. We want to know what -3 is given f of 3. So again, you'd be integrating from -3 to 3 of f prime of x dx, saying that that is equal to f of 3 minus f of -3. So if I'm looking for -3, this is the case where I subtract the area of the integral away. So f of -3 is equal to f of 3 minus the integral from -3 to 3 of f prime of x dx. So f of 3 is 9. I'm subtracting from it the area of my semicircle. So that's 1/2 pi, radius 3. So I'm subtracting from 9 pi halves. The graph of f prime consists of 2 line segments. So again, taking into account, you shade between the the x-axis and the line. So that is all of the space I am looking for. Everything in yellow. Between the x-axis and the line, not below it. So like this is where I was saying like some of us on that quiz, like we did this triangle instead of just doing like what I shaded in. Okay? So we are looking for all of the following points given this. So -3, and we're looking for f of 1. So f of 1 would equal f of -3 plus the integral from -3 to 1 of f prime of x dx. So -3 is 6, and now I'm going to add the area under the curve from -3 to 1, which is this triangular space here. So that triangle has a base of 4 and a height of 4. So we get 8. Okay, so you have f of 1 equals 6 plus 8, which is 14. Now, to find f of 4, you have two choices. You can go back to your initial condition, or you can say f of 4 equals f of 1 plus the integral from 1 to 4. So instead of having to add the triangle and the initial condition f of 3, you can start at 1 and find that space. Does that make sense? So you know f of 1 you just calculated to be 14. So now I can change my bounds to be the 1. So I can say it's 14. And then here, this triangle is a little trickier. So your base is from 1 to 4, which is 3. Your height is got to be at that 90-degree width there. So your height is actually at 3 down to -2. So you're 1/2, 3, -2. So the 2's cancel and you get -3. I put the -2 on there because this is below. So even though the triangle is positive, that's below. So I'm going to take 14 minus 3 to get 11. And then 7. I'm going to start at f of 4 again, which is 11. And now I'm going to integrate from 4 to 7, which is a quarter of a semicircle. So it's going to be 1/4 pi. The radius from 7 to 4 is 3 squared. So it's 9 5/4. So 11 plus 9 5/4.